Hello everyone, welcome back to the class. In this channel, as always, we solve mathematical questions or mathematics related questions or those questions which are scientific and calculation and they need calculations which students find very hard, but we make them very easy. Today, as usual, we have a question from some 3 students. Their question is how to construct a Pascal's triangle and how to use it in the binomial expansion. So number one is how to construct Pascal's triangle. Pascal's triangle. The question 2 is how to use Pascal's triangle in the binomial expansion. So we have questions. We have 2 questions. We have to solve them. First of all, let's remain with the first question. Let's see how we construct this triangle. Constructing this triangle is very easy and it should not be a problem. For example, the first one is 1. It's always like a pyramid or like a triangle. It's always of this shape, a pyramid shape or a triangular shape. You should view it like this. So the first on top or at the peak, at the apex, we have 1. Then this one plus 0 is 1. We put 1 here and we add another one here. Then you add this one and this one. This one plus this one is 2. Then you put another one here, you put another one here. Then this 2 plus this one is 3. This 2 plus this one is also 3. Then you put 1 here, you put 1 here. 1 must be at the end. You can see both ends is 1. Then as we go down to the base, this 3 plus this 1 is 4. This 3 plus this 3 is 6. This 3 plus this 1 is 4. Then you add 1 here, you add 1 here. You continue like that. For example, let's continue to the next step. Let's go together. This 4 plus this 1 will give us 5. This 4 plus this 6 will give us 10. This 6 plus this 4 give us 10. This 4 plus this 1 give us 5. Then you add 1 there and 1 there. It is endless. It is sorry for that. Our whiteboard is falling. The Pascal triangle is endless. It can continue. It is infinite. It is infinite. It can go till nth term, where nth term is infinity. So, in fact, after constructing it, you can see it is 1, 2, 3, 4, 5, 6. Whereby this is power 0, power 0, 1, 2, 3. Like that. Leave alone the powers so that whatever I've mentioned, so that you don't get confused. Forget about the power 0 I've mentioned. But this is how to construct a Pascal's triangle. You start with 1, then you say this 1 plus 0, 1, 1. Then you add this and this, you get 2. When you get 2, you add 1 at the end. Then you add this, you get the result 3. You add this, you get the result 3. Then you add 1 at the end. You add this, like that, like that. Very clear. Very clear. Now, question 2. How do we use it in expanding a binomial expression? For example, using Pascal's triangle, and the binomial expansion. So we have solved the question 1, how to construct the binomial, how to construct the Pascal's triangle. So if you have a question on it, you will ask me, then I'll explain. Question 2, we are in question 2. We want to use it. For example, give me any algebraic expression. For example, let's expand x, maybe let's expand a plus b, maybe raised to power 3. Let's expand this, a plus b raised to power 3. We want to expand it using Pascal's triangle. So we say 0, 1, 2. This is what I say about that time. Now you understand it. When I was saying power 0, nini. Sorry, I've spoken Kiswahili, not nini. 0, 1, 2, 3, 4, 5. So if it is power 3, we use the third line. We start with 0, 1, 2, 3. We'll use this. 0, 1, 2, 3. We'll use this line. So if it were raised to power 4, power 5, like that, I'll show you how to do it. But this one is raised to power 3. So we'll say 0, 1, 2, 3. We'll use this one. This one here. This is the third line. So we say 1, 3, 3, 1. Then we say a, the first term a, the first term a, the first term a. So now here's where we apply the power. So this will be a raised to power 4, a raised to power 3. No, not to power 4. It was raised to power 3. We start with a raised to power 3 because it is raised to power 3 here. A raised to power 2, a raised to power 1, a raised to power 0. Then we go to b. You say b, 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 b. Pay attention here. You see here, the powers were reducing as you go down. This side, at the side of b, the power will reduce as you go up. Whereby you say b raised to power 3, b raised to power 2, b raised to power 1, b raised to power 0. You've understood? Let me be clear again. AB in the bracket raised to power 3, you want to expand using binomial triangle, Pascal's triangle. You have to construct the Pascal triangle the way you have constructed it. Then it is raised to power 3, you count 0, 1, 2, 3. This is the third. So we use this line whereby it has the digits 1, 3, 3, 1. 1, 3, 3, 1. You write it like that. Then you write the first term. Our first term is a. We wrote it here. Then it is power 3. The power starts with 3 as it reduces downwards. 3, 2, 1, 0. Power 3, power 2, power 1, power 0. Then you put the second term, which is b. Then its power reduces as it goes up. 3, 2, 1, 0. Then the trick is anything raised to power 0 is 1. So but anything raised to power 0 is 1. Anything times 1 is it's that thing. Any number times 1 is that number. So because b raised to power 0 is 1, 1 times this one, you can assume it, you can remove it. A raised to power 0, you can remove it like this. Until there we are clear. After writing, giving them the power, you realize that the power increases in the first term as you go down, and the second term, which is b, the power decreases as you go up. Now it's very easy. What you do, you start with the first one. 1 times a cube, it is a. 1 times a cube is a cube plus 3a square. Let me write it here. So we come and say 1 times a cube is a cube. A cube plus 3 into a square. B raised to power 1 is just b plus 3. A raised to power 1 is a, b squared plus b cubed. This is the answer. That's the answer. Suppose now we raise it to power 4. Let's delete everything here. Now raise it to power 4. Expand that. We go back to our Pascal's triangle and we count 0, 1, 2, 3, 4. Now we are using this. We are using this line. And that line, we can see it has 1, it has 4, it has 6, it has 4, it has 1. When we come to our first term, which is a, so here will be a, because it is raised to power 4, we put it here, a raised to power 4, a raised to power 3, a raised to power 2, power 1, and power 0. Then we write the b. Sorry. The b should be here, b. Now b will start from here, raised to power 4, raised to power 3, raised to power 2, raised to power 1, raised to power 0. Then, don't forget, anything raised to power 0 is 1. 1 times anything is that thing. So we can assume it. We remove raised to power 0, we remove raised to power 0. So we remain like that. Then we say our answer will be 1 times a raised to power 4 will be a. My a still looks like that one of a tadpole. A raised to power 4 plus 4 a cubed b plus 6 a squared b squared plus 4a because raised to power 1, b cubed plus b raised to power 4. That's our answer. Suppose now it is raised to power 2. We count 0, 1, 2. Let's do raised to power 2. Let's remove everything here. Is a plus b squared. A plus b squared. Using Pascal's triangle, we'll count 0, 1, 2. Where it will be that 0, 1, 2. We use this line, which is 1, 2, 1. Then we write a. Then to power 2, to power 0, to power 1. No, sorry. To power 2, to power 1, to power 0. Then we write b, to power 2, to power 1, to power 0. Then anything raised to power 0, you know it is 1. So 1 times this times this. So you assume you assume it. You assume this one here. Don't worry, Kiswahili is sweet in my mouth. That's why sometimes I find myself speaking Kiswahili. Some Kiswahili words. Now, this is what we have remained with. Then you say equal to. This will give us a square. 1 times a square is a squared. This will give us 2 ab plus b squared. That's the answer. I think that one is clear. If you don't understand it, I'll come back again and clarify. If you have a question on that, on how to use how to construct Pascal's triangle and using it in binomial expansion, if anything is not clear, just comment there or send the email at anyangajak@gmail. I'll reply and I'll come out clear. Whatever is not clear, please don't fail to ask again. In Kiswahili we say kuuliza sio ujinga. Asking is not stupidity. Asking is learning. We learn by asking things. Once again, welcome. Subscribe. If you have another question which you need to be solved, send the question. We'll solve it together. Asanteni sana.